Well, hi there. Welcome everybody to this presentation, The Building Blocks of Big Data. This is the Bank of England's journey to delivering a big data capability. My name's Adrian Waddy. I'm the technical lead on the current implementation of the next generation of platform. This is my colleague Nick.
Hi, Nick Vaughan, the domain SME for data analytics and modelling.
And we've also got Eloise Hines on there. She's not presenting, but did some sterling work helping us pull the slides together, so we thought we'd credit her. As is traditional with these things, I'll tell you what we're going to tell you. So we're going to touch on the bank, who we are, what we do, before mentioning a sort of a historic IT, where we started from. Briefly touch on our sort of data warehousing years and what have you before moving into the current big data solution that we have, and in particular focusing in on a single use case before talking about the sort of future platform and what the future might hold for us, and finish with some questions. So who are we and what we do? Just before we start that, actually, I'd just like to talk a bit about why we're here. For selfish reasons, we, like pretty much every other organisation, are recruiting people in the area of data analytics, data engineering, data scientists, and we find it surprising how often we have to explain the import of the things that we're working on and how they are sort of linked to society in the UK. So we're trying to be proactive about it, and also as a public sector body, we have a responsibility to be open and transparent. And in fact, in 2014, the then chief economist Spencer Dale described the bank as being arguably the most powerful and elected institution that our country's ever seen, and we need to respond to that by becoming more open and more transparent. So we're doing our bit, that's why we're here. So the Bank of England, it was formed in 1694 when we sent Hortonworks our sort of spiel to describe this. It was taken by one of the copywriters and sent back for our validation. They obviously, on the west coast of the States, thought that was a typo, and it came back as 1964. So it was formed by an Act of Parliament, and a little sort of subset of that document is that it was formed to promote the public good and the benefit of our people, which chimes nicely with our current mission statement. At the time, it was rather pithily summarised by a diarist called John Evelyn as a public bank set up by Act of Parliament to fund a war. And this was something that our current Governor, Mark Carney, in 2014 referred to when he described the mission is timeless, but what we think we need to do to achieve it has evolved. In 1694, it meant funding a war with France. Now, and reflecting on the financial crisis, it means maintaining monetary and financial stability. So what's different about the Bank of England? Well, gold is one of the differences. So that's one of 10 rooms that I understand exist in right in the centre of London, in the office where we work. Unfortunately, my pass doesn't get me into any of those rooms. It's the second largest collection of gold in the world. It's somewhere in the region of £135 billion worth. Only the New York Fed has more. Virtually none of it is central bank gold, actually. We provide a service to commercial institutions to hold their gold for them, and they, which they have to hedge against a downturn in the economy. And actually, there's a unique part to it. Everywhere else, where if you store your gold with them, when you get back the same number of fine ounces, which is the measurement. In the Bank of England, you get back the exact same bar. So each one of those bars, they know who that belongs to. It's embossed and stamped, and the exact same bar will go back to you should you choose to bring it back out. So what do we do? There's sort of a wide variety of things, in particular regulation and policy. And operations. So regulations is things like the PRA, Prudential Regulation Authority, which is responsible for the regulation of some 1,500 financial institutions. We do stress testing, so each year get the largest financial institutions and run their figures against a potential global downturn to see how they fare. We've got a policy as well, so we're responsible for the financial stability of the systems in the UK. We have also we apply interest rates to achieve an inflation rate independently, although the inflation rate is set by the government of the United Kingdom. And then on the operations side, we have banking operations, have markets as well. We manage something like £485 billion worth of assets for the citizens of the UK. And we also have RTGS, which is a real-time gross settlement, which is a way that banks move money between them, and they net off during the course of a day something like £650 billion worth of transactions each day. And individual transactions that are of high value, for example, if you buy a house, they go through that system as well. Now, it really does sit at the centre of the financial systems. It's comfortably achieves its 99.95% uptime. However, that's not as important to us as data integrity. And the reason for that is if money moves through that system, it's as good as giving someone a tenner and walking away. It's now theirs. And they could spend it and it could be gone. So it absolutely has to be right. We'll touch on now on a bit of historic IT. If any of you in the room actually, is anyone working sort of large or old organisations, sort of over 1,000 people, more than 30 years old? A handful of you. So some of you will recognise this. A server in a cupboard. That was our beginnings. It was sort of in the 80s and 90s. When we did collect data, it was by department only, so sometimes we collected the same data more than once. The analysis, the insight was only shared with the, within the siloed sort of department. Then we moved on to the 1990s and into 2000s. We got a centralised IT function, and with that came centralised data centres, we started to benefit from the economies of scale that provided. It allowed us to move into what I'll characterise as a data warehouse years. Basically this was in response to a growing demand from the business for the storage, analysis and insight being derived from data. Also in particular automated processing, so when firms submitted data to us, the pipeline delivering the appropriate report was an automated one. High availability became the norm. Some of these systems grew to having from small numbers through to having hundreds or even thousands of users, and so HA became the normal for these systems. And also it's a bit around improved capabilities. All the time the technology was allowing us to do more and was becoming more cost effective, so the size of these things expanded. So it allowed us basically to have affordable scaling, to get away from silos by departments. We had a data set which served the entire bank, regardless of what department we were in. And we were dealing with significant volumes. So some of our analytics platforms have hundreds of millions or even billions of rows, which in a telco terms isn't large, but in our terms is. We scale to add tens or even hundreds of millions of rows a year, and we have hundreds or even thousands of users on some of those systems. So given the fact that we realised the step change in our capability, and that the progress that we made could only really be described as a success, why the need to change direction? And I think that can be characterised as basically for three reasons. One, on the regulation side again, was to do with the EMIR regulation, which is a use case Nick will talk about in detail in a moment. There's also policy, the changing nature of the role for people at the bank. And there's also operations as well, and increasing complexity in our estate. So same question again, so who works in an organisation over 1,000 people, more than say 15 years old? Have we got many? Yeah, so maybe a third of the room. There's a good chance you might recognise this picture. This is our data analytics estate, the sort of spaghetti junction. And we this is complex to manage. It's not the full story, actually. There's 128 different data analytics systems that our domain's responsible for. And there's significant cost and complexity in operating that. But it goes further as well. The analysts in the bank relied very heavily on their internal network to know what data existed and where it existed. And even when they discovered it and managed to get access to it, if the data that they wanted to combine didn't fit on their laptop, they had no real place to do so. And increasingly there is demand for using some of the open source tooling that was becoming normal in the industry. As well as that operational fact, and this is about our role really, the diagram shows the prevalence of mathematical functions and statistical functions in economic publications as a percentage. And we can see for the last 50 years that economics was becoming more and more quantitative. And then suddenly there is a massive step change in 2008. And of course, all of those mathematical functions, all those publications need data on which to operate.
So while the increase in mathematical functions is interesting, far more relevant for our big data journey was the commitment of the G20 nations at a meeting in Pittsburgh in 2009 to do something about making sure that the likelihood and the severity of any future crash is greatly diminished. And given that the derivatives market in particular was given the was identified as providing the initial trigger for that crisis, it was to that market that focus shifted. So in 2013, the European Parliament, the Council of European Union, brought in the European Market Infrastructure Regulation to bring in greater insight and greater oversight and regulation to that market. Now, it's a pretty big market. According to the Bank of International Settlements' latest figures, the current nominal value of open over-the-counter transactions is around about $595 trillion. Given that London's position as a financial centre, we as a central bank to regulate entities within the UK, that meant that we had to collect in the region of 50 million transactions every day. At the moment, 85 million on a busy day. Now that might not seem like the biggest solution here. You're going to hear from Telefonica that they're ingesting 16 billion in a day, but for us, it was a step change. We needed a different data architecture. So EMIR brought in central counterparties. They existed as intermediaries for the derivative trades. So you'd post your collateral and then they would execute that transaction for you and submit information about the derivative trades to one of 6 trade repositories. Now those repositories exist for us as regulators to draw down the data that's relevant within our jurisdiction. What made that challenge even more hard for us was there were 80 files across those six different repositories. There was nothing to dictate that a transaction could be submitted to just one transaction every single time, so those central counterparties could submit to any of the 6, so we had to collect all of the data from 6. Any one of those files could be 20 gig at a time, and the structures and the schemes were different across the trade repositories and also within the repositories. Because over time, as that regulation settled, changes were introduced, tweaks were made, structures changed. So it was a significant challenge for us to deliver this platform to the deadlines that we were needing to meet using relational technologies. A few other things that happened that also are relevant for our big data journey. As Adrian said, the creation of the Prudential Regulatory Authority, that almost doubled our headcount. And given that we needed to regulate thousands of banks, building societies, credit unions, insurers, again, there was an increasing amount of data that we needed to collect, store. And also since the crisis, there's been an increasing interest in exploiting new and novel data sets, larger and more, say, exploiting Google data for indicators in sort of shifts in employment and attitudes around the housing market. We're also lucky enough to host the Centre for Central Banking Studies in Threadneedle Street. That's a body that brings together global regulators to explore other central bankers from around the world to explore themes and issues that are of interest. And this was the first one that really looked at technology exclusively and big data as a thing. So I think it's significant because it shows that it's no longer a technology problem. It's something that our other colleagues across the bank are seeing as changing the markets that we regulate. opening up opportunities for the big banks to exploit and gain a competitive advantage, but also technologies that we could use ourselves to exploit and tap into for greater insights. So things debated here were kind of the ethics of storing increasingly granular data sets, the type of our responsibilities for taking those and storing them and protecting them. So our reputation is absolutely critical. Also significantly, there's a change of governor in 2013, and one of the first things that he did was commission an independent review of the bank, the state it was in at that time, looking for kind of efficiencies and perhaps, and ideally coming up with a new target operating model and better ways of making use of our data. For us, it wasn't exclusively focused on technology, but it was a key theme, and that the results of that review that went public, and he stood up and published those, called for a central data platform. And also the review went further and identified Hadoop as a technology to underpin that central data platform. But we had problems because we didn't have the skills in-house at that time to build our own large clusters. We didn't have pots of money that we could throw at huge, invest in a massive kind of data, huge kit to push into our data center. We need to make sure we get value for money, but also pretty low appetite for risk. We didn't want to be one of those institutions that burns lots of cash and doesn't get much for its money. So we realized pretty early on that we needed to partner with a vendor. And that's what we did. So we went out to through a lengthy procurement process, and we acquired this solution. It's an appliance. There's storage infrastructure inside, and the vendor was responsible for configuring that, installing the software on top, and also plugging the holes that we were acutely aware of that existed at that time. Apache Ranger was still incubating. We were very concerned about the security model around this, given that we were going to put some very sensitive information on that. And as I say, this is what we ended up with. But I would recommend that none of you go out and try and procure one of these. A couple of weeks before we were going to go live with our EMIR project, the vendor pulled the plug on this as a product, which on the one hand gave the opportunity for lots of naysayers and people kind of around us to maybe accuse us of having made a disastrous mistake, and this has been, the communications around it were really, really difficult at the time. But once the dust had settled, we realised that actually we'd gone from nothing within less than 2 years to a production state, serving up EMIR data to our analysts. And we also proved and built up our skills enormously in that short period of time. We went from completely nothing to being confident enough to now build our second data hub. So in the new year, we'll have another one coming online that will be 5 times bigger in multiple data centers. But this is going to limp on for now. And we're kind of but we are getting a huge amount of value out of this. This is how we implemented our trade repositories project. And we didn't get this right first time or second time. I think we had to, the first time we presented a single table, 16 terabytes in size to our analysts who were for a long time telling us in technology, we're the experts, give us the data, get out of the way, and we'll do the rest. Their queries were taking half an hour to run. They were iterating over 17 billion transactions multiple times. The fact they were returning anything in 30 minutes was pretty impressive, but they were used to relational databases that respond in seconds. So there were a few iterations, and this is what we ended up with, and this is how it is right now in live. So we take the files from the trade repositories, we unzip those, they're CSVs, and we just store them in a raw zone. We then start giving them structure. So for each repository, given that they have their own unique schemas and structures, they get loaded into ORC org tables and appended, and that gives them the structure that, as you know, more efficient for Hive. In our refine zone, we start bringing in, merging the hooks for our reference data, our local, say, legal entity identifiers, perhaps other sort of currency conversion mappings. And then we load them into our consume zone. And this you can think of as taking data from a warehouse, pushing it into a mart. These are structured, aggregated, and reduced in size to respond to very particular use cases. We have 3 now up and running. One of them we can talk about because that's public, and that's the contract continuity. That's our end-to-end process at a high level, and just to emphasize the importance of this stuff. In our financial stability report on the back end of last year, as we have a responsibility to do, we flagged what we saw as a risk to the financial system. And that was that, at the point of Brexit, which was due to be next week, we flagged the risk that there would be derivative trades, contracts open at that point in the region, with a value in the region of around £41 trillion that would be in a relative state of limbo. Something needed to happen to it. I'm not going to answer any detailed questions of that, but thankfully, because we went public with it, because we have this data set and we were able to process billions of transactions, we were able to flag this as a very significant risk, and those that were and should have been concerned with this were able to deal with it and alleviate that risk. So we're in a better place now. Who knows when Brexit will happen. But it also had many other benefits for us. We proved that we could do this. We built up blueprints. We built up the idea of places to apply data quality rules. We also made it clear that this stuff is difficult. And we were started to bring more of our colleagues on the business side who thought it should be easy and should be easier. Once they got their hands on Spark clusters, once they went from running R locally on a laptop to in a distributed framework, they realized actually this stuff's difficult. They need to know a little bit more about the underlying infrastructure. So we've been able to, through some pair programming and some assistance from a small external consultancy, get everybody up to speed and into a better place, and perhaps a more kind of realistic view on what's achievable. So I think I've spoken through that.
So just going to touch on sort of next generation, something we're implementing now and looking to deliver at the early part of next year. It's at the moment it's called in very original fashion Data Hub 2. Key themes around this are, well, automation. Automate everything as much as possible. We're going to continue with dynamic provisioning to give us capability to spin up new clusters as we need. Our first platform was virtualized, and we're going to continue with that because it gives us the flexibility that we're after. One of the key differences in terms of a live environment is we're going from effectively a single cluster with one or two clusters where marts are to 3 separate production clusters. This largely reflects the CloudBreak offering on Azure, and it means we'll be able to tune these clusters to workload. It also helps us with the conflict we found between an analytical community who are very skilled but need to move fast and iterate around their analysis, and the need for quality metadata so that we don't end up with a data swamp, so that we understand our data and it means something to the business. And the approach is to have the data lake, the ingest cluster, which is going to be the engine doing the work, and then a query cluster which will be tuned for low latency, high concurrency, containing highly modeled data, and then also an analytics cluster which might have the same data, might also have raw data in there if that's what the analysts want to work with. And there we'll have a lower level of data governance, allowing for that train of thought analysis. It means that their sort of flow and output can increase, and it's only when they want to bring that back in, effectively put technology SLAs around a particular reporting pack, that then the high level of data governance would come back in again. In terms of the sort of sizing, as Nick mentioned, each site is 5 times the size of our current and is dual site resilience. As part of our sort of explaining what we do, we actually also go out to secondary schools and explain, this is what technology in the bank does. And one of my colleagues did this recently and asked me for some stats on Data Hub 2. So they are there at the top, but it occurred to me that 15 and 16-year-olds are not going to really bother too much about terabytes, etc. So I've translated it into iPhone X's for you. So in storage, it's equivalent of 1 1/3 tons of iPhone X's. In terms of memory, it's the equivalent of a stack of iPhone X's, 35.5 meters tall. And in terms of cores, it's 84 iPhone X's, which probably tells you that there's quite a bit of processing power in your phone. So over to you.
Yeah, this is what it looks like, or did before the merger. So we have the end-to-end process or pipeline that we described in the Trade Repositories project, the European Market Infrastructure Regulation, but that's given us a blueprint for all other projects that are coming our way. As I say, the securities project is even bigger than TR. But also, as our strategic review called for, that central data platform, so that we think we can use and leverage Atlas to deliver that platform that we can audit our data, we can track through range and integration with our internal AD, what people are doing, the data that they're using, how they're deriving their insights, and track that, so we can make sure that if any publications are, which they are all the time, pushed outside the bank, we can retrieve the research and the analytics that went into publishing and making those decisions. Adrian mentioned we're going to have separate clusters on top of our data lake, which is going to be our foundational platform. We think we're going to be making use of the likes of sort of LLAP initially, and perhaps Druid in our operational environment. So as we plug in Tableau and more of our kind of BI operational workloads, we'll be supporting more concurrent users here, but also our analytics environment is really important to us. We have over 400 researchers and econometricians at the Bank of England. We are kind of a global centre for economic research. And they'll be doing things in there that we could, I don't think I'm just speaking for myself, but some of our PhD grads and kind of specialists like Louisa over there, they'll be doing things that we can't get our heads around. So we just need to support, give them the infrastructure and the frameworks to be able to productionise their pretty complex at times models. But as a technology function, we'll be retreating to the perimeter of that environment. We'll support it, we'll keep it running, but what happens within there will be driven by the business. So they'll be developing their own pipelines, they'll be publishing into, for them, production of their models. And the outputs will at times be going back down into our data lake. So perhaps in the future we'll get to a point where the next stress test will be running efficiently through our pipelines and the models going back and circulating through this architecture. And we have lots of other tools around the outside for automation and code management.
So, a bit about lessons learned. Technology. There's no excuse for not planning, but the pace of change in the open source community, as you probably all know, is so high that you can plan for 2 years ahead, and should do, but also be prepared for it to change and for the technology to change under you. And I think we were a little bit surprised by that and need to communicate that more clearly.
I think it's also fair to say it's an institution that's 325 years old. Some of the frameworks and the ways of doing things in technology were a little bit restrictive at times for introducing open source technologies and things that perhaps, you have a roadmap, 6 months later something's dropped out, something's new's come in, and you have to take back to an authority who lots of beard stroking and frowning aren't too impressed. It's not like it used to be with Oracle or SQL Server. So you need to bring lots of others around you on that journey, and it kind of accepts it is difficult, but the benefits are such that it's worth it.
And also metadata and governance, and in particular dealing with that conflict of analysts needing to move quickly, but also the data being clearly defined and being understood by the business and achievable by the business. And also what really struck us was the people and processes, which Nick's touched upon around that. We need to sort of carry hearts and minds on this business and maybe change some of the target operating models because of the rapid nature of development.
And that stuff's difficult. You're asking people to change the way they work, to relinquish sometimes control over something that they've been able to do within their team, to buy into this central platform that's there for everybody. We've got a view for delivering a platform for the enterprise where we still are fairly sort of siloed sometimes in the way people work, and the divisions, they have very distinct roles, some for regulation, some for markets, banking. So getting everybody to play nice and contribute to a central platform where everybody needs to do the stuff that no one likes to do around kind of capturing metadata and making sure that we know enough about our data sets as we onboard them onto our platform so that someone else in another part of the bank can search for them, find them, and understand what they mean, and perhaps decide whether to use them or not.
And then finally, really, there's tenacity and experience is sort of, and creativity is all linked. Some of this stuff is hard. We'll get some of it wrong. But the experience you gain is absolutely invaluable, and so just try things, just keep trying things, be prepared to fail, and sometimes bring some creativity to your problem solving. So I think that kind of brings us to the end of the presentation section. Happy to take any questions if anybody has any. I think there might be a microphone. Should we see if we can get a microphone sorted out for you?
I'm pretty loud, I think.
Okay.
I'm curious about, maybe this isn't even appropriate for this kind of a session, but I'm really curious when I think about the size of your data lake and how much raw data you might have coming in, whether you had a particular strategy to deal with attribution of data so that you could trace where data came from all the way through all of your various processes. I don't know if that's something that's...
Yeah, so we, the platform that we currently have was going to be using Ativio for that, but given the fact that the platform was effectively end of life at point of go live, we didn't leverage it that much, so we sort of manually did that. In the next generation that we're doing now, we're looking at Atlas/Navigator, delete as appropriate, to help us in that. In particular, what was interesting about Atlas was the two directions in which not only can you see the lineage of the data set, but you can also see downstream as well and see where that data set is used, which is of particular import to us to know what the implications of any changes might be. Yeah. Oh, there you go.
Hi. The bank came into some criticism a couple of months ago from the select committee about the costs of, is that even working?
It's not, it's on, but
I'll just talk about it.
Is possibly distracted. I'll go away then.
That's fine with me.
Yeah, so there was some criticism for the IT costs of the bank overall from the select committee. I wondered if kind of this platform and a lot of the stuff that you guys have been implementing here is directly linked to trying to bring those costs down and trying to kind of change that culture over the coming years when 2020 when this comes into play.
I think that first of all I'd say that as foot soldiers I'm not sure I have the insight to comment on the discussion between governors and the select committee. What I would say is that the bank is rigorous about being transparent about its procurement process. So how so I think this is part of that process, is being transparent and clear and ensuring the value is being delivered.
Yeah, I think it is right to say that the strategic review in 2014, when it was published, called for a more efficient use of technology, reducing those silos. So every time we build a new system, we don't need a UAT instance, we don't need a dev instance, we don't need a kind of a live instance. All of them have their own kind of infrastructure and management overhead and licensing implications, whether they're a SQL Server or an Oracle. Actually, something that uses open source technology that we can put all of our data onto and use more efficiently is definitely part of that drive to make more efficient use of technology and bring down costs. But also, more importantly, I think it's just the capability it gives us to tap into new data sets.
So I wanted to ask a quick follow-up as well. Is just it sounds like you were kind of a little bit burned by this experience with the Data Hub 1 and an open source technology kind of disappearing in front of you. I kind of wondered whether the kind of sudden merger of Cloudera and Hortonworks gave you any headaches, or if that's just going to kind of...
I would say the headaches are more on the communication around it, because we've been in the weeds for so long and understood when we looked at the challenge that was set us, it was pretty daunting to think that in less than 2 years we could become experts in building, configuring, managing a large cluster, let alone build a solution on the top of it that was secure and can deliver what we needed to. So even though we partnered with a vendor who pulled the plug on a project, if you step back and look at what we managed to achieve in that space of time, I don't believe we could have got to where we are now, where we're now comfortable to take that challenge on now, because we've proved the technology and we have the skills in-house to go again, but 5 times bigger, and the vendor is going to row back because they've been burnt probably more than we have, and they'll do what they're good at, and the infrastructure beneath the software will take on everything above the line and sort of power on, I think.
Yeah, so I wouldn't describe it being burnt, and the merger is from a technical perspective, isn't causing us headaches. it's just something we just have to communicate clearly and carefully, and, you know, to win hearts and minds as we go on the
We've
journey.
been singed a little bit around the comms because it's easy for folks to point at the failures and things we got wrong, because you get a lot wrong very quickly. Perhaps we need to keep an eye on the successes and make sure that everybody's aware that you've kind of passed a significant milestone, or for the bank to be processing 16, 17 billion transactions in less than a few minutes, and that those reports going into the Financial Policy Committee and decisions being made off the back of it that impact everybody's lives, that's a significant thing. But it doesn't tend to get shouted about. It's the sort of downtime of things going bang and kind of impacting local teams that make the most noise.
Anyone else?
Hi, just one question regarding all the disaster recovery. Did you put another data hub to deal with it, or how did you manage this case?
So we have got dual data center capability in the one we're building out, and it's built on the storage is on Isilon. It was built on the VMware offering VX Rack, and with that, it's a software-defined data center. They call it SDDC, and with that, a significant DR capability effectively comes with it, assuming it's configured correctly. It will be almost entirely active-passive, with the exception of the metadata store, which will be highly available and stretched across both sites so that you have it available if you do fail over. But that is a significant change for us. Currently, our disaster recovery is to reload the data. Anyone else got anything? Yeah, sure.
I saw one of the slides that you were using Apache Spark as well, and you mentioned also you do like pair programming. Do you use specific tools for performance and tuning reasons, or are you using Apache metrics in any way?
So, on the pair programming piece, I think it's worth pointing out that, I mean, that's quite normal in a technology environment. But what we found really effective was a data scientist with a data engineer. So someone from technology sitting with someone who is a domain expert on the data, and that leveraged their analytical capabilities and knowledge of the data, combined with a data engineer's understanding of how to model data and how the underlying HDFS storage is working. And we yielded really strong results from that. And that will be a design pattern approach as we onboard data. We will look to obligate projects to take that pair programming approach at the end of it. In terms of Spark, do you want to talk about the
yeah, we use Spark for the transformations in the pipelines, for the engineering task. We're now, we've deployed a Spark cluster dedicated to our trade repositories data, and we're loading the data from our data lake into that, and then giving our analysts and our researchers and specialists in the trade repositories data, and helping them get up to speed with PySpark and SparkR. They have ambitions to bring MLlib and do more, increasingly more sophisticated, bring more sophisticated use cases to that data set. Before, it was all sort of localized on laptops. They'd take maybe a day's worth and spend a series of weeks processing a day at a time, aggregating, threading it all together. It was a laborious task and it was error prone. Now we're helping them wrap all that code up and run on all of the data in its entirety using Spark. Package that up, click of a button, move on to the next use case. So that data science focused Spark cluster is maybe a couple of months up and running now, but we're starting to see some really sort of good, positive messages and things coming out of that cluster. And most healthy is the business side of being able to self-serve. They're very smart. They know Python and R inside out, but now they're getting to grips with the idiosyncrasies of taking R locally to Spark R. What works, what doesn't, what needs to change, how you need to distribute data to get the most out of it. They're starting to get to grips with that now and starting to power ahead, which is satisfying to see after all the.
Okay, thank you.
Yep. I think we've got time for one more question, if anyone's got one. If not, wrap up. Very good. Thank you all very much for coming. Thank you.